Hello everyone, welcome back. In the previous lectures, we learned about the optimal choice and the demand function of a single consumer, given his preference and budget constraint. But in the market, there are many buyers. So in this lecture, we will sum up the individual consumer's demand to get the market demand. Assume there are only two consumers, Tom and Max, in a market. Their individual demand curve for good X is shown in these two graphs. When the price of X is P1, neither of them have demand for X. Therefore, the total market demand is also zero. When the price is P2, Max demand is XM2, while Tom still does not buy any of X. Because there are only Z2 in the market, the total demand is XM2. When the price is P3, Tom would like to buy XT3, and Max would like to buy XM3. Then the total market demand is XM3 plus XT3 when price is P3. Therefore, the market demand at a given price is Tom's demand plus Max's demand at that price. Similar to this example, no matter how many buyers in the market demand is the sum of all the individuals' demand at a given price, holding all consumers' income and the price of the other commodities unchanged. Each consumer's demand for X is a function related to the price of X. Here, Xi is the individual demand function of consumer I. The market demand function for X is the sum of all the individual demand functions. The market demand curve shows the relationship between the quantity demanded by X and its own price, while keeping the income level and all the other prices constant. If other prices or income change, the market demand curve will move. A point on the demand curve represents the demand quantity of commodity X at a given price. We can also explain the demand curve from another angle. It represents the market price at any given demand quantity. Such a relationship can be expressed by the inverse demand function. Any demand function can be transferred to an inverse demand function. The demand curve shows that the quantity demanded of a commodity responds to its price. But we usually want to measure the sensitivity of response more accurately. In economics, we use elasticity to measure the sensitivity of one variable with respect to another. For example, income elasticity of demand measures the sensitivity of quantity demanded of a commodity with respect to the income level. Price elasticity of supply measures the sensitivity of the quantity supplied with respect to the price. In this lecture, we will focus on a very commonly used elasticity, price elasticity of demand. Price elasticity of demand is a measurement of the sensitivity of quantity demanded of commodity I with respect to the price of commodity I. It's defined as the percentage change in quantity demanded of X divided by the percentage change in its price. It shows how much percentage change in the quantity demanded caused by 1% change in price. Consider a very tiny change in price. After rearrangement, price elasticity of demand can also be expressed as the derivative of the demand function multiplied by the ratio of price to quantity demanded. Because most commodities are ordinary commodities, That is, demand falls as the price rises, so the price elasticity of demand is usually negative. However, we are concerned about the sensitivity of the response, that is, the absolute value of elasticity. A higher absolute value represents a stronger response. So usually, when we talk about the price elasticity, we refer to the absolute value, and the negative sign is omitted.
For example, the elasticity equals 3 means the quantity demanded decreases by 3% as the price increases by 1%.
And the elasticity equals to 2 means the quantity demanded decreases by 2% as the price increases by 1%. The former is a stronger response. It is more elastic. If the elasticity of a commodity is greater than 1, we say the demand for the commodity is elastic. For commodities with elastic demand, the quantity of demand is very sensitive to price changes. When the price rises by 1%, the decline in demand will exceed 1%. Oppositely, if the elasticity is less than 1, the demand is inelastic. And if the elasticity is equal to 1, it's unit elastic demand. The price elasticity of a commodity depends largely on how many close substitutes it has. If commodity X has many close substitutes, then when its price rises, consumers will choose its substitutes, and the demand for X will drop significantly, so the demand elasticity of the commodity will be great. Now, let's try to calculate the price elasticity of a linear demand curve, such as P equals to A minus BX. This linear demand curve has a constant slope, minus B. That is the derivative of price with respect to the demand for X. Inversely, the derivative of demand for X with respect to price is minus 1 over B. Substitute quantity, price, and the derivative into the formula of elasticity. The result shows that the price elasticity of a linear demand curve is not a constant, but a function with respect to price. And the vertical axis intercept, P equals A, the demand is 0, and the elasticity is infinite when P equals to A over 2. That is, at the midpoint of the demand curve, the elasticity is 1, and the horizontal axis intercept P equals to 0, and the elasticity is also 0. On the upper half part of the demand curve, P is greater than half of A. The elasticity is greater than 1, while on the lower half part of the demand curve, P is less than half of A. The elasticity is less than 1. So, for a linear demand curve, every point on the curve has a different elasticity. Moving from up to down along the demand curve, the elasticity gradually decreases from infinity to 0. Why is the slope the same, but the elasticity different on a linear demand curve? That's because we measure the sensitivity by percentage change. On the upper left of the curve, the quantity demanded is small, so a unit of change in the quantity is a strong response. For example, when the quantity increases from 1 to 2, it doubles. That's a significant change. But on the lower right of the curve, the demand is already of a large amount. 1 unit of increase in demand is insignificant. For example, the demand rises from 100 to 101. It's a negligible change. Now, we are going to apply the price elasticity of demand to solve some problems in reality. Imagine you are a manager. If you want to increase your revenue, should you raise the price or lower the price? The answer depends on how your customers respond to the change in price. It is the price elasticity of demand. Total revenue equals to the price per unit multiplied by the quantity sold out. And in the market, the quantity can be sold out is the demand of the consumer. It's a function with respect to the price. So the total revenue is also a function with respect to the price. Use the product rule to calculate the derivative and rearrange the equation. The result shows that when elasticity is greater than 1, the derivative of total revenue with respect to price is negative, which means that the price increase will cause a drop in total revenue.
Because when the demand is elastic, the consumers are very sensitive to price changes.
The fall in demand is greater than the rise in price. So the total revenue will decrease. As we have analyzed before, the demand for a commodity is elastic, mainly because the commodity has many close substitutes. So price increase will cause the customers switch to other substitutes. In this case, bulk chip is a better strategy. Conversely, when the elasticity is less than 1, the derivative of total revenue with respect to price is positive. An increase in price will lead to an increase in total revenue. That's because when the demand is inelastic, the effect of increasing prices on the demand is small, so the fall in demand is less than the rise in price. Then the total revenue can be increased. If a commodity has few substitutes, the demand for it usually inelastic. Then the seller can make a larger revenue by charging higher price. From demand function, we could derive inverse demand function. So the total revenue can also be written as a function with respect to the quantity demanded. Then we can find out how total revenue changes as the demand quantity changes. We define marginal revenue as the additional total revenue generated from the sales of an additional product. It is equal to the change in total revenue divided by the change in quantity sold out. When the quantity demanded changes in a very tiny amount, marginal revenue is the derivative of total revenue with respect to the quantity demanded. The value of marginal revenue shows how total revenue changes as the quantity changes. If MR is positive, selling more product will increase the total revenue. Oppositely, if marginal revenue is negative, selling more product will decrease the total revenue. Now we calculate the marginal revenue by calculating the derivative of total revenue with respect to the quantity demanded. The result shows marginal revenue also depends on the price elasticity of demand. When the elasticity is greater than 1, the marginal revenue is positive, which means increasing sales quantity can increase the total revenue. In this case, a small price cut can greatly increase sales quantity because the demand is elastic. Therefore, the total revenue is increasing as the sales quantity increasing. In contrast, when the elasticity is less than 1, the marginal revenue is negative. In this case, in order to increase sales quantity, the firm needs to substantially reduce the price because demand is inelastic. Therefore, increasing sales quantity will reduce total revenue. From the above discussion, we found that since there is a relationship between price and demand, we can write the total revenue as a function either related to price or related to quantity demanded. In practice, it depends on the decision variable we choose. When we are going to make a price decision, we calculate the derivative of the total revenue with respect to the price. When we make a quantity decision, we calculate the derivative of the total revenue with respect to the quantity demanded, which is the marginal revenue. In this lecture, we learned about market demand and the price elasticity of demand, and examined the relationship between elasticity and total revenue. In next lecture, we will combine the market demand and the market supply to find out the market equilibrium. See you next time.